In our first derivative video, we took a look at the power rule, which is kind of like the basic derivative rule. Here we're going to look at the product rule. So what I'm going to do is give you an example of two binomials that are multiplied together. Product, of course, means to multiply. So if we have, let's say, 3x squared plus 6 and negative 7x to the fifth minus 8x. All right, what I'm going to do is refer to the first one as g of x and refer to the second one as h of x. So to take the derivative, the product rule tells us f prime x is equal to the first times the derivative of the second. So there's a multiplication in between there. And we're going to add the second, the unchanged second, times the derivative of the first. And that is your product rule. So I'll put a nice box around that. So here we go. If we follow this rule, f prime x is equal to the first times the derivative of the second. The derivative of the second, we're just going to use like the basic power rule, right? So negative 35x to the fourth minus 8. That's the derivative of h. Big plus sign. I'm going to write h without changing it times g prime. So the derivative of the first one. Power rule tells us 3 times 2 is 6, x to the first. And that's really it. You can simplify if you'd like to, but for our purposes, we're just going to leave it just like that. So the derivative of f of x is right here. Let's try another one. So let's say we have j of x, and j of x is equal to 8x to the 1/2 times negative 10x to the negative 2 minus 3x to the fourth plus 1. So the derivative of j, which we'll call j prime of x, is equal to, again, this is the first, and we'll call this the second. I'll use a different color for that. Call this one the second. You can label them different letters if you want, but the basic rule is you take the first one and you don't change it. So 8x to the 1/2 times the derivative of the second one, which is, let's see, I'll put it in parentheses, 20x to the negative 1/3 minus 12x to the third. This is the derivative of the second trinomial here, the second polynomial. Plus, we're going to write the second one unchanged, and we're going to multiply that by the derivative of the first one, the blue one here, 8x to the 1/2. So it's the power rule, 1/2 times 8 is 4x, and we're going to subtract 1 from 1/2. 1/2 minus 1 is negative 1/2. Alright, so simplification is probably a good idea here. We know based on our rules, right, if you have the square root of x, that's also equal to x to the 1/2, so this is actually 8 radical x. And negative exponents go into the denominator, so this is actually equal to 1 over x to the third. 20 stays at the top, x to the third goes to the bottom. And same thing here, negative 10 stays, x squared goes to the bottom. And right here, it's a combination of the two. It's a negative rational exponent, so the 4 stays up top. Square root of x goes to the bottom. And I'm sure you can probably simplify some of this stuff more if you wanted to bring the fourth term in front here to make the exponents descending. That might be a good idea, but those are two examples of the product rule.